Are you ready? Hi everyone, so today we are going to explain about C++ program for COVID-19 cases. So here are our group members. I am NORASHIKIN binti AZMAN with metric number D201910899490.
I'm NORAFIQAH binti ZULKARNIN with matrix number D201910899492.
I am SYAZATUL AMIRA binti AZIZ with matric number D201910899494.
I am Zahirah binti Yahya with matric number D201910895511. Introduction. COVID-19 is a disease caused by a new strain of coronavirus which reported identified on 31st December 2019 that happened in Wuhan City, China. The virus spread globally and affected many countries. The three Asia countries that we are going to investigate the data related to COVID-19 cases are Malaysia, Singapore and Brunei. The reason why we choose these three countries because we can easily get the data for daily deaths, recovers and active cases. All the data we get from the website. Here we show the link and the screenshot of the website for Brunei, Singapore and Malaysia. Next, I will continue to explain the upper part of our programming codes. The first line of our coding, #include iOS stream, is a compiler preprocessor directive which tells the compiler to include a header file named iOS stream. The header file of iOS stream is needed to support the console input and output in C++. Since in these programming codes use the input files, hence we need to use the header file named fstream. So at the second line of our coding is #include fstream, which to tell the compiler to include the header file named fstream. Another header file is iomanip, where we put at the third line #include iomanip. This header file is needed as we are using the function setPrecision and setW. SetPrecision we use with manipulative fix to set the number of decimal places for some of our output data, and function setW we use to set the field width on our output. After the third line, the user-defined mathematical functions are used in our coding that done by implementing #define for two constants, r equal to 92 and c equal to 4. R and c are representing the size of array 92 times 4. 92 is the number of rows since the total days for the 3 months is equal to 92, while 4 is the number of columns for the dead, active cases, recovered cases, and death cases. Next, the line using namespace std is used to access the C++ standard library. For examples, the command cout and endl. Since we want the variable and the functions in our coding are properly classified and organized, hence we use class and object in our coding. So the class declaration we made after the fifth line. The name of the class is country. The member variables are TA, TR, TD, and TTL, which represent for total active, total recovered, total death, and total overall cases. While for the member functions are AA, AR, AD, PA, PR, and PD, which represent average and percentage for active, recovered, and death cases. We declare TA, TR, TD, AA, AR, and AD as INT data type since the total and average is the number of people, while TTL, PA, PR, and PD as double data type. To make all the members public so that it can be accessed to other part of the coding, we declare them after the public keyword. By general form of class declaration, we will declare all members of the class within the curly bracket, and not to forget the semicolon after the closed curly bracket. After the class declaration, we made the function prototype. We use function prototype because we want to declare the function first without implement them. The function will be implemented after the main body. All of the functions prototype that we made with int return value type are to compute the total of the 3 cases for each country, which means the compiler need to have the data first which was read from the input file at the main body so that it can calculate the value and will not give the random numbers for the output. We also just need to read the input file once for every country. Continue to the implementation of the member functions. The member functions are AA, AR, and AD are used to compute the average for each cases. So all these member functions will return the value of the total of its cases divide R, while for members PA, PR, and PD are to compute the percentage of the 3 cases. So these 3 member functions will return the value of its total cases divide total overall cases times 100.
I will explain the coding for Malaysia part, which is how is the coding to display output we want. First, we need to create an input file to put all the data we have, such as date, active cases, recovered cases, and death cases from Malaysia, and name the input file as malaysia.txt. Next, the coding. First, we need to declare object for class country, which is my. Then create an array for the data, which is my r plus 1 c plus 1. Next, this is the coding to make the output more neat. Since we use input file that have our data, we need to write ifstream ifp semicolon. To read the data from the input file, we write ifp.open malaysia.txt iose, and below that, we write what we want to display the output. Next, we initialize active cases for Malaysia as AM equals to 0, recovered cases for Malaysia as RM equals to 0, death cases for Malaysia as DM equals to 0, and total Malaysia cases as DM equals to 0. The data type for AM, RM, and DM are integer, which is an int, and for the DM is double. For array output, nested for loop is used. The nested loop we can see as in matrix form, which is the outer loop represent row and the inner loop represent column. We have 92 rows and 3 columns. In the same inner loop, we also compute the summation of all cases, which is active, recovered, and dead cases. Then, we call all function that we already declared without implementation. The implementation of the function we put after the main body. We write as AM equals to total active Malaysia TAMMY, RM equals total recovered Malaysia TRMMY, and DM equals to total death Malaysia TDMMY, and then end line to go to the next line. Next, use dot operator to access a member function that will be used to display output. We write as my.ttl equals to tm, my.ta equals to am, my.tr equals to rm, and my.td equals to dm. Then we display all the information, which is total, average, and percentage for active, recovered, and dead cases. Next, we close the file with ifp.close. As we can see, this is the function file that we write after the main body. The function file we declare as a function prototype at the beginning of the coding. We create function file to compute the total active, recovered, and dead cases.
Then the output will display all the data in input file malaysia.txt and all the information needed.
For Singapore, firstly, we need to create an input file that contains the overall data cases in Singapore, which are active, recovered, and dead cases of COVID-19. We name the file as singapore.txt. After that, we have to declare object for class country, which is ST. Then, to create an array of output data, we have to use nested for loop. So we use the format of ifp.open to read the data from input file of Singapore and use the format of ifp.close at the end. For the nested for loop, the outer loop represents the row, while the inner loop represents the column. Next, we have to compute the total active, recovered, and dead cases STS, which is submission of overall cases of COVID-19 in Singapore. So we have to call a function that we have to declare without implementations. The implementations of the function is given after the main body, which are AS is defined as total active Singapore in bracket TAS in small bracket SN semicolon. Same goes to RS, which is total recovered Singapore, and DS total dead Singapore, and end of line C out N semicolon. Then we use the dot operator to access the member function. Lastly, this is the function file that we declared at the function prototype of the beginning of the coding that we have implemented after we create the main body. The function of this step is to read the data we have opened in main body. After the coding complete, the output will display all the data needed.
Next, for Brunei, we need to create an input file named is brunei.txt and fill in with the data for active, recovered, and death COVID-19 cases.
For the coding, firstly, we have to declare object for class country, which is BN. Then the array for data of Brunei is integer BN R+1 C+1. To read the data in input file, we have to open that file first with format ifp.open, open bracket brunei.txt, ios double colon in and semicolon. Then we just create a table for date from March to May, active, recovered, and death cases, so that the data will display in correct order. Next, we have to assign initial value for active Brunei AB, recovered Brunei RB, death Brunei DB, and total Brunei DB. To create array output, we use nested for loop. The implementation of nested loop can be seen in a metric in which the outer loop represents the row, which is 92 rows for the COVID-19 cases from March to May, and the inner loop represents the columns, which is 4 for date, active, recovered, and death cases. Write the summation of active, recovered, and death cases in Brunei is written as TB in the loop. Next, we have to calling a function that we have declared without implementation. The implementation of the function is given after main body. AB equal to TABBN, RB equal to TRBBN, DB equal to TDBBN, and end of the line. Then, the dot operator is used to access the member function. Brunei dot with total equal to total Brunei. To display total active COVID-19 cases in Brunei, we use bn.member.ta. For total recovered, we use bn.member.tr. Next, we use bn.member.td for total death. For average active, we use bn.member.aa open and close bracket, bn.member.ar open and close bracket for average recovered cases, and bn.member.ad open and close bracket for average death cases. For percentage active, we use bn.member.pa open and close bracket, bn.member.pr open and close bracket for average recovered cases, and bn.member.pd open and close bracket for percentage death cases. Don't forget to close the file and cin.cat to hold display until the windows close. This is the function file that we declare as the function prototype at the beginning of the coding. We have implement after we create main body to read the data that we have opened in main body. Then the output will display all the data in input file Brunei txt and all the information needed. Next, I will explain about the linear graph. We have produced 3 line graphs which are about active cases, recovered cases, and death cases from March until May 2021 for 3 countries of Malaysia, Singapore, and Brunei. Firstly, the title of our first graph is Active COVID-19 Cases from March to May for Malaysia, Singapore, and Brunei. The y-axis is labeled as the number of active cases, while the x-axis is for the date. From the indicator, orange line is for Malaysia, yellow line is for Singapore, and green line is for Brunei. We can know that Malaysia has the highest number in daily active cases, followed by Singapore, and Brunei that has least number of cases. The number for Malaysia has decreased on March and rising again on April until May. The number of active cases in Malaysia is between 10,000 and 1,000 people. The number of active cases in Singapore has increased from March until May, and the value is between 100 and 1,000 people. While for Brunei, it seems the active cases is stable, and there are a few days that the number of infected people are rising just a little bit more than 10, but most of the days are less than 10 people.
Recovered cases linear graph with title recovered COVID-19 cases from March to May for Malaysia, Singapore and Brunei. The y-axis for this graph labeled as the number of recovered cases and x-axis is labeled as death. Same goes like the graph before. The orange line is for Malaysia, yellow line for Singapore and green line for Brunei. Based on the graph, the highest number of recovered cases is Malaysia and Brunei has the least number since it is more horizontal than Singapore. The number of discharged people in Malaysia has decreased from March until the middle of April and increased again until the end of May. For Singapore, the number of recovered cases is more than Brunei. As we can see, the yellow line is more upward than the green line. While for Brunei, the number of discharged people are mostly 0 cases for the 3 months. The number of recovered cases for Singapore and Brunei are fewer than Malaysia since their daily active cases are also few.
Death cases linear graph, the last graph that we have produced by using Excel. The title of the graph is Death COVID-19 cases from March to May for Malaysia, Singapore and Brunei. The label for y-axis is number of death cases and for x-axis is death. Similar to the active and recovered cases graph, orange line for Malaysia, yellow line for Singapore and green line for Brunei. From the graph, we can see that Malaysia has the highest number of death cases between the 3 countries. The number of death cases for Malaysia from early March until the middle of April is fluctuated around 0 to 10 people and continue rising at the end of April until the end of May, while the cases for Singapore and Brunei are stable. There are a few days the cases for Singapore increased, but mostly 10 cases for the 3 months. There are no death cases within the 3 months in Brunei and make this country as the least in number of death cases. In conclusion, from the active, recovered and death cases linear graph, we can interpret that the more the number of daily active cases, the more the number of recovered and death cases. Overall coding. So after the explanation of all part of the coding, here is the arrangement. The first part is the pre-processing followed by the function prototype, continue with the implementation of member functions and the main body. The last part of the coding is the implementation of the function prototype, which also the function file to compute total of 3 cases. Overall output. Here is the overall output from the coding we made. That's all from us. Thank you for watching.